All right, guys. So I'm doing some serious unpacking. It's way later than it should be, but it's the way it goes. Yeah, I got glasses on because I should have them at school, and I do, but I just forget to wear them. So I talked to you guys the yesterday on the other video, and we haven't talked in class today. And we're going to take some time unpacking this in class. This I'm finding out is like extremely important in the world of series because this is why in that one set of notes I said that a geometric sequence is or geometric series is our friend. It's because of this piece right here. So when we get to a power series, which we'll explain what that is, and I'm still learning exactly what a power series is. It's starting to make a lot more sense right now. I feel like I'm in calculus 2 learning it like you guys. Uh, this right here, this formula, which I just talked about, which is A over 1 minus R, that piece right there is crucial in creating functions that are represented by a power series. Okay. So differentiating and integrating power series, no big deal. You guys are going to be able to understand that. That it's a little complicated at first, but I get it. Uh, Now, when we look at this, I want you to look at the format of this right here, and I'm just introducing it real quick, and it'll make sense. I'm going to look at the format right here. This is really A over 1 minus R. Took me about an hour to figure this out, guys. I was just sitting there looking at it, and then I'm like, holy smokes, it's A 1 minus R. Because then this becomes 1. That means our function, our R, right? Our R is X, which is a huge thing for the power series. Okay. That's a huge thing. So now I look at this one. How do I make this here this? Well, that's going to be 1 over 1 minus negative x. My r is negative x right there. So that's a crucial piece. Then you're like, well, how the heck does this fit into it? Well, if I differentiate or integrate these things, this can turn into 1 over 1 plus x, which in turn turns into 1 over 1 minus negative x. So these things start kind of pulling together. So like, how does this work? This is 1 minus negative x squared. My r is negative x squared. This one, I'm not sure yet. This one here, it's that 1 over 1 over 1 plus x squared when we take the integrals and stuff and derivatives of those things. So we're really focusing in on this. This is why geometric series is our friend. So if we go back earlier and I said right here, A, this is our key piece right here. This is crucial for us needing figuring out the series, because once we figure out the series like that, so like this type of thing where this is A and then this is R, those are crucial pieces uh, for us figuring out a bunch of things that are coming at us. Okay, so the power series talks about physical universe. The key to this is we can take some really ugly equations and we can create this idea of what they converge to. And it may not be converging specifically on a number, but it may be converging on 1 over 1 minus x, or the natural log of 1 plus x, or whatever like that. Okay. So this is what our power series looks like. I'm not going to worry about the form too much. So this is our zero term, our first term, our second term, our third term, those types of things. And it comes from this series right here, okay? And this is kind of our basic geometric series, okay? Now, one of the key pieces, and it'll come later when we talk about some different convergences and stuff, and I think section 10.4, but it's centered at 0, okay? So that's kind of the idea. It's going to be centered at 0. And just if it's centered at 0, then we've got our x minus a, meaning it's our shift. So if it shifts left or right to 2, and then that's going to be accounted for with a shift. So it can be either way. So we can say uh, if it's not centered at 0, it's centered at some term a, or I should say some value a, and then all it does is change this to x minus a over n. And then a is the center. So these things are centered somewhere, but for now, we're going to worry about them being centered at 0. Okay, so we're going to be centered at 0. Now, so they give us this a lot here. 1 over 1 minus x is represented by the power series 1 plus x squared plus x cubed plus blah, 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 blah. And it's x to the n power. Okay. Yeah. X to the n power. That's the power series. Okay. So how does this become this piece here? Well, this is where I kind of was like, oh, okay, wait a sec. How the heck are they going there? Well, this is 1 over 1 minus r. So that means r is equal to x, right? And x and a is equal to 1. So then we have this idea of our geometric series, which is n equals 0 to infinity, right? Of a times r to the n minus 1. So if we take that piece here and we're looking at it and we go a, well, a is 1 and r is x, right? And it's my 0 term, or it's my first term. I take that, x is 0, that's going to be equal 1. So there's my 1. And then my second term, n equals 2, right? Sorry, this is n equals 1, guys, sorry. And then n equals 2. Excuse me, n equals 2. We have 1 times 2 x to the 2 minus 1, and that's this one. So this becomes that. So we're going to take this formula, which is based off of this, and we're creating a series based off of this piece, right? So now I know that this series equals that series. And so they just say by differentiation. So we need to look at this and go, okay, well, they want me to represent this piece here. So we need to take the derivative, right? So when we set this thing up, which is kind of what we talked about there, I know that this is going to be, not that, sorry. Control Z that one. I know that this piece here is going to equal my series I created prior to this, right here. And now from that, I just take the derivative of both sides, right? I take the derivative of the left side and derivative of the right side. So if I take the derivative of this piece here, remember this is going to just be 1 minus x to the negative 1. I subtract 1, and then it moves it down here, okay? So now I get my answer. Oops, excuse me. My back is killing me. My answer is the derivative of this is 1 over 1 minus x squared. And then the derivative of 1 is 0. It's not there. The derivative of x is 1. The derivative of x squared is 2x. The derivative of x cubed is 3x squared. And the derivative of this is multiply n down, and subtract 1, and so we get this piece here. So this representation is the same as that derivative, okay? So those are going to be the same idea. So this power series is the equivalent to that piece there. Now, all right, so I'm kind of looking at this one here, term by term differentiation, and I'm it's too formula-y for me, so I haven't been able to look at it as much as I wanted to. So I'm still working with this piece. I'm not sure where it comes into play just yet for the problems we're working on, but I'll deal with it when we get there. And so what we're just saying is that uh, that the interval that it converges on is the same for f and f prime. That's kind of really all I'm getting out of this, and so I'm not going to worry about that too much. But I really want to focus in on the idea of how they're coming up with these things. So let's look at this here. So we got 1 over x minus -1, right? Because this is a over 1 minus r. Big epiphany right here, guys. I mean, that's just huge. When I saw that, I was like, oh, I made it. I figured, well, I didn't figure it out. At least it made me feel better. Uh, and so then we look at this, and our new one is n equals the first power, and this is going to infinity. And we have a is 1, right? So a is 1. R is, I did that backwards. Sorry, guys. This would be 1 minus negative x. I did that totally backwards. And then we have negative x to the n minus 1. That's my geometric series. So let's plug these things in. If I plug in 1 for n, 1 minus 1 is 0. That cancels out, and there's my first term. My second term, 2, I put a 2 here. 2 minus 1 is the first power. Negative x times 1 is negative x. Then if I go to the third power, I put a 3 here. 3 minus 1 is 2. Negative x squared is positive x. That's why these things alternate. Okay. So this one here, when I plug it in, this is my 1, 2, 3. This is n equals 4. So when I plug in, I'm going to move over here because I don't have a lot of room. And when I plug this in, I get 1 negative x to the 4 minus 1. Well, this here, the 4 minus 1 is 3. Negative x cubed is negative x cubed, which is that one right there. So these negatives, you got to watch out, they alternate. And that was a huge thing for me. So what does this become? This becomes negative x to the n power. That's our idea over here. So negative x to the n power, because n to the 0 is 1. Negative x to the first power, negative x to the second power, negative x to the third power. That's what this becomes. Now, we are centered at 0, between -1 less than x, which is less than 1. So this is our, this is our center equals to 0, okay? Now, I'm still kind of fuzzy on the -1 to 1, but that's the idea behind it, okay? So now it says find a power series to represent natural log of 1 plus x. And well, if we integrate these things, we're going to work backwards. And so that's what we got to recognize. That's why they say recall that 1 plus x is the derivative of the natural log of 1 plus x. So when we integrate the series, we'll find the series for a natural log of 1 plus x. So we're going to do integration now. Okay. We're going to do integration. So, so we take this 1 plus x and then we integrate both sides. All right. So we're going to integrate the left. So when we integrate the left, we're going to go from 0 to some value of x. Wow, now we're dealing with the fundamental theorem of algebra, so that's pretty nice. So when we integrate 1 over t plus 1, we get natural log of 1 plus t. When we integrate this side, we get t. Then we do our 2 over t, and then we get our 3 over 3. We get our 4 over 4. So we work our way through. So now when we look at this and we create this equation, we know that we have a negative 1 in front, okay? And then, so this first term is a negative 1. And then and then this would become, my brain just went dead. This is our first term. Why is that messing my brain up? All right. Well, we end up with, because we're integrating. Sorry, it's a totally different setup. So we end up with our first term is, our first term becomes a t. That's still not making sense to me. So I'm going to have to tackle this one. Okay. I see where they came up with all of this. So I'm going to talk you through it. This may take a little longer than I wanted, but I'm almost done with this. So if this is my first term, right? This is n equals 1. Is that n equals 1? Yeah, that is. That's n equals 1. I'm going to have to mess around with that. Okay, so we integrate. So I'm going to have to take some time, and I'll probably talk about it in class. So when we integrate these sides, this is the integration piece that we get. I'm going to have to tackle this one here. My explanation I had in my head just died on me, so I'll come back to you guys in class. And then the natural log of 1, and then 1 plus x. So then we just end up evaluating it from 0 to x, and that's where we end up here, okay? This one here, again, I'm not too worried about right now. It's this piece here. So what are we really saying with these pieces here? What we're saying is that this power series converges on that. That's literally what we're saying, okay? So when we get down here, we're saying that this power series here, this power series converges on this graph as between negative 1 and 1. And so this is what I mean here. So if we take from negative 1 to 1, right? If we take from negative 1 to 1, and we graph the natural log, where's that graph at? The natural log of 1 plus x. The natural log of 1 plus x is going to look like this, right? That's kind of what it looks like. So what we're saying is that between this boundary, the series, the farther you go out, the series more and more reflects this graph right here. So like if I take x to the first, let's just take this one here, x, that is a slope that looks like that, right? That's an ugly slope that I just drew, but you got the idea. So it'd be 1 over x. It doesn't touch it, but it kind of mimics it, right? And then if I go x over negative x squared, I'm going to get a parabola that kind of goes like this, right? And it starts to mimic that. That would be this first series. And then if I do the third series all the way to here, we end up with a graph. Let me change the color. I can't draw graphs on this very well, guys, and I'm super sorry, but I'm trying to figure this thing out for you guys. It'd be an x to the third that does something like that. Well, that's a horrible line, but you guys got the idea. So it comes up, it goes off, it kind of follows the line, and then it goes this way. So as you go out, it starts mimicking this line, this teal line that we have here. It starts mimicking that as we go out. So it starts mimicking that line right there, but just between -1 and 1. That's why we say the power series, this power series is centered at x equals 0. Okay. I'm going to go ahead and stop at that point right there and let that process. And then we're going to kind of have a class discussion now. All right. I will talk to you guys later.